Today we'll look at a interesting use case. So this came out of POC that we did. Ultimately, what it required was us to show how we can dynamically scale our data integration mapping across an agent group. What we see here is something that we came up with after the discussion with them. What they were looking for is that they have data sources. So in this example, what they wanted us to prove was how we can bring data in from their OLTP database, the transactional database, into the data warehouse, and essentially show a solution where we can split the data processing in a cluster of nodes, right? So here I've drawn out different agents, and we have a feature in Informatica Cloud which we introduced in the last release called agent groups, and basically it's a agent cluster, okay? And so what they wanted us to be able to prove is that we can actually distribute the load processing across the agent cluster, okay? So what we did was that we took different capabilities in the cloud offering and showed a solution that the customers felt that would meet the requirement. In fact, they were quite excited about what we showed them. So what we ended up using is agent group, right, which basically allowed them to add as many agents as they needed, and parameterized mapping. So these are basically integration mappings which are parameterized so that they can you can specify on a particular node what type of range to process. So in this case, we ended up using database key ranges as a way to partition the data set. Okay, we use the ICS REST APIs so that we can introduce a dynamic aspect to the integration. And finally, ICRT process played a big role here because we used a process flow which had the logic to split the data set into the different key ranges and then distribute the execution of the individual tasks on the grid of nodes. So we'll take a look at how that works. So basically, the method is define the agent group with a cluster of nodes, right? Create a single mapping in ICS using the mapping designer, which has parameterized aspects of the mapping that allows you to specify like the source key range, like what data subset do I want to extract from the source, or what key range do I need to use within the lookups and so forth. And then we created an ICRT process to launch multiple instances of this particular mapping with specific key ranges on the agent cluster. The other requirement here was that, in the beginning, is that it is an elastic cluster, so you couldn't really hard code any specific key ranges. Okay, so they'll be able to add any number of nodes as needed, and the solution should work as is without changes. Okay, so that's something that we had to take into consideration. So let's see what this looks like, and I'm going to actually open up the product and show you the pieces. So at the end of the day, we ended up building a cloud mapping designer mapping, okay, which initially in the POC we kept the mapping simple, but actually when you ran the POC, we used a mapping that the customer had created, and it had about 4 or 5 lookups, and it was basically doing like a slowly changing dimension kind of a flow in a way. So it was fairly complex. And what we did was within this mapping exposed a parameter which could actually be specified through a REST API from the ICRT process. The next step was to be able to actually create the process itself, and which had the logic to be able to look at the key ranges, split the key ranges, and then launch instances of the task using this particular task flow and run it on the grid. So we'll actually take a look at how that works now. So let's first take a look at the mapping. And now this is not the actual mapping we use in the POC, because the mapping is is at the in the customer org, which we can't access right now. But this is another version, or at least to illustrate. I'm using this particular mapping that will open up. So as you see here, this is a very in this case, it's a simple mapping. All it does is reads data from a data source. So the data source could be a database. In this case, in the particular example that I show you, it is a file, but in the POC, we actually used a database. And as you see here, it's a very simple flow. It's sorting the data, filtering based on certain criteria, doing sub lookups for augmentation, transforming the data, and then loading to the target, right? So in the customer use case, the source is the OLTP database, and the target is the data warehouse, right? In the future, the target will be Redshift. And they had a whole bunch of lookups to be able to augment the data. They're also doing some amount of, there was logic within the mapping to look for existing records and then maintain history and so forth, right? So those mappings can get fairly involved. And here the trick behind, how we can take this mapping and actually kind of make it work across different data subsets is to be able to parameterize a mapping so that you can define how you want to subset the data through the parameter. So here, if you look at the filter condition, so in this case, the source is a file, but for the customer use case, we use the filter at the database. So if you look at the filter, you'll see that it has been parameterized, and there is an attribute called myFilter, which holds the parameter, the filter rule, right? So if I can set the filter dynamically and say this is the range you want to operate on, I'll be able to create a task on the fly to be able to work only with that data subset. Okay, so that's a mapping, and now let's take a look at how the process, what the process does. Okay. Now, to make this work, so this is the process that actually does the distribution of the integration task across the grid. Okay, so it is a loop, and that goes through the key ranges and creates task instances for each key range subset, and then runs it on the grid. So we'll take a look at how that works. So before we do that, the question you may want to some of you already know that using ICRT process, you can actually run ICS tasks, right? So it's maybe not all of you know, but basically ICS tasks can be invoked through REST APIs. And ICRT process obviously can call REST APIs. So within ICRT, there are native capabilities to be able to run any ICS task. Okay, so what that allows us to do is to build like a task flow or a work or an equivalent of a Power Center workflow in a way using ICRT process, so where you can actually orchestrate execution of tasks within this flow. Now, so what we did was use that capability, and in addition, what we needed was that the ability to create some of these task instances on the fly. And to do that, we're using the Informatica Cloud REST APIs, which actually lets you generate these instances dynamically through the REST, via REST. And so if you look here, so let me walk you through the process first, and then we'll go back and see how the REST APIs actually work. Now, the input into this process. Now, we assume for this use case, the actual number of nodes is not known ahead of time. And actual key ranges can vary as well. So the user can specify the key ranges dynamically. So the input to the actual process is the range start, the range length, and the max range. So let's say it's a database table with with a million with keys that go from 1 to million. So range start will be 1, the max will be 1 million, and the range length is how you want to split it up. Maybe it's 1,000, maybe it's 10,000. So it really depends on how you split it up. May depend on how many nodes you have and so forth. So that's dynamic. So the user would specify that. Okay. So when that when that information comes into this process, then first we initialize. The initialize is basically, in this case, is just a login into Informatica Cloud. And then there's a create task instance. So this is where a lot of the magic happens in terms of how do I create a task instance dynamically for a particular key range. And if you look closely, what you will see here is that the input that you will see that remember the filter that was parameterized within the mapping. We see the actual filter expression that's encoded here in this step. Okay, so the current filter is set to order ID greater than or equal to temp.currentStart and order ID less than temp.currentEnd. Okay, so these are current start and current end are process variables which are set for each iteration of the loop. Okay, and it's calculated based on what the values the user specified. And then there is a task name that is generated dynamically based on, of course, the range values and things, so that you can actually, when you look at the task executing, what range it will be executing for. And then there's a target name. In this case, the target is a particular CSV file. In the POC was actually a relational database. And then once the task is created, it's run on the agent group. As far as running on the agent group, today we have a REST API to be able to take any ICS task and run it on an agent. So you can do the same thing for an agent group. You just run it on an agent group. The agent group takes care of distributing the task, and basically there's a load balancer which distributes the task within the agent group. So let's say you have a 5-node cluster, the load balancer will basically today round robin and distribute all the execution in those nodes. Okay, so from ICRT process perspective, all it does is submits a job to the load balancer, and then the load balancer takes care of the distribution. Okay, and then once that's done, we update the range, so we go to the next subset. Okay, so if you look at what the next subset is, that is where we increment the current start and current end values are pointing to the next subset effectively. Okay, and then we check whether we've reached the end of range or not. So if you've gone to the max range, then we know we've reached the end. So and we are done in terms of spawning out all the different tasks. Otherwise, we loop back here into create task instance, which will go and create another instance for the next range. Okay, so we don't know how many instances will be created because it really depends on the input ranges that are specified by the user. And once that's done, there is a little loop here as well to make sure that all the jobs ended. Of course, we could do more things here in terms of looking at if the jobs execute successfully, do they need to be restarted, and so forth, right? But we kept this example simple. Here, all it does is loops through the activity monitor using the REST API again, and then checks if there is any of the jobs still executing, so it stays in the loop until they all exit. Okay, so that's the flow. And so if I run this, I'm going to go run this right now, and then we'll take a look at and then we'll see how that works, and I'll come back and show you how some of these pieces work in a little bit more detail. So let me go back to so to launch this, I have I'm using the advanced REST client, and this is the process, the endpoint, and the input here is the data is coming from a file in this particular case. Of course, the POC was a database. This is the range, right? So the range start is 100, the range length is 30. I can make it whatever I want, right? And then that the max is 300. Okay. So if I send this, now I go back to Informatica Cloud. Just hope that everything works. I go into Activity Monitor, and you'll see that there'll be you'll see tasks being spawned. Okay, so these are tasks that are dynamically created and sent to the grid, the agent grid for execution. And in this case, we have and you see that there's a whole bunch of tasks that got created and executed. Of course, the data sets are so small that they just ran like this, right? So, of course, for the customer use case, they had a much bigger table, so it took some time. But the idea is that I was able to split the table into chunks and then run them on smaller nodes and gain efficiency through that, right? So if I look, so the actual agent grid in this case, it's just a 2-node grid, and as far as distributing the task of the 2 nodes, the load balancer took care of it, right? So I could have had 5 nodes here, then the load balancer would have distributed across the 5 nodes. So if I go back to the activity monitor, everything is ended, of course, now. Let's go to the activity log, and then you will see that all of these jobs executed. And if I open up some of these, you'll see that this executed on, this job ran on this node, which is actually running on an EC2 instance. And this particular job here ran on my local agent running on my laptop. Okay, so it's kind of distributed the load. Okay, so if you take a look at, okay, so how did this happen? So these are all task instances that were created dynamically. So to look at the actual task, let's go to anything that you create in Cloud Mapping Designer. When you're running it, you create something called an MCT task, which is basically a mapping configuration task. So the ones here that you see, the process order with all the numbers, they are the ones that the ICRT process flow generated through the loop. Okay, so if you look at any one of these, then you will see that within here, what's changed is the actual filter condition that got pushed in through the REST API via process via the process step. Okay, so you can see that this is the range 150 to 175. That's the subset that this particular mapping was dealing with. Okay, so that's conceptually, that's the idea. The thing is that for a given, what was exciting about this for us, as we did it, and for the customer who saw it, is that they saw different possibilities, right? So typically, in terms of job distribution, the system takes care of it; it's automatic. But then you cannot configure it to work the way you want it to work, right? So that's a lot of optimizations are done when you know how the data is distributed. So the things that the process could have done in addition here is to actually profile the data source to see what are the optimal key ranges based on data distribution and things, and then dynamically generated the task, right? So there's a lot of things that you can do, and especially in process, you can actually access the data through JDBC and so forth. So there's a way you can actually do count stars and things like that. So we could have done a lot more, made it a lot more sophisticated. So another example that we didn't use in the POC, but also made sense, is more about how we can, in a lot of big data use cases, the tables are very wide, okay? And so I know there's a recent POC that we are doing, or we are involved in right now, with the TDM, Test Data Management product, is that there is one Salesforce object that has about 800 columns, right? So the question is, one way to partition data set is by ranges and so forth, right? Looking at the data values. The other way to partition is to actually partition based on columns, right? So if you can shard the database based on columns, then you can take subset columns and then distribute the processing of that table on a grid. So it's very useful for replication and things like that if you're dealing with very, very wide tables. So so here is another quick example where the input here is actually, let me open up the actual process. So the example we chose was, there is using Cloud Mapping Designer, there is a mapping that does effectively profiling of data sources, right? So it looks at columns, does aggregations, and looks at how many nulls there are, what is the min, what is the max, what is the domain of values. It's a very column-centric operation. So you could actually take that table, split across the columns, and then distribute that load across the grid. Okay, so this particular process is very similar to the one that we saw earlier, but in this case, the input that's coming in is actually not a key range, but it's actually a column range. And the actual this is what the input looks like, right? Again, we could do it in different ways. So what this has done is taken the source table. I mean, typically this would be like a very large table with hundreds of columns, but for this example, we have it's split into 3 subsets, right? So 3 columns here, 2 columns here, 3 columns here, and then this is the source file that it's reading from. And so when I run this, what it does is it actually splits the source based on columns and then distributes it. Okay, again, it's a different type of problem. It's a big data problem again, but it's a different type of a problem, right? And again, we're using task orchestration and mappings to be able to kind of deal with this distribution as well. Okay.